All right, let's talk about something you've probably seen 1,000 times, but maybe never really thought about, the columns in Microsoft Excel. You know, A, B, C, and then it gets weird with A, B. It seems so simple, right? But there's a really cool mathematical puzzle hiding right there in plain sight. And today, we're going to crack it. So let's just dive right in with the big question. If column A is 1 and Z is 26, what number is column ZY? Now, take a second. Think about it. Whatever number just popped into your head, it's probably not the right one. This is trickier than it looks. Okay, so at first, it seems totally straightforward. A is 1, B is 2, you just go down the alphabet all the way to Z, which is 26. Easy enough. But then you hit AA, and that's 27. AB is 28. And right there, your brain kind of short circuits, right? Because suddenly, just counting the letters doesn't work anymore. This is where the simple pattern breaks down and reveals a way more clever system. So to figure out this Excel puzzle, we're going to do something that might seem a little weird. We're going to take a step back and look at something we use every single day without even thinking about it, our own number system. Believe it or not, the secret is hidden in something you already completely understand. Think about a number like, say, 254. How do we really understand what that means? It's not just 2 plus 5 plus 4, right? That would be 11. No, we intuitively know that the position of each of those digits is everything. That 2 isn't just a 2, it's 200. And that simple idea, that positional value, that's the absolute key to unlocking this whole thing. Let's actually break it down. You've got the 4 in the ones place. The 5 is in the tens place, so it's worth 50. And the 2, that's in the hundreds place, making it 200. See? Each spot is a power of 10. That's why we call our system base 10. Keep that term in your head. Base 10. It's going to be important. And here it is. This is the big reveal. Excel isn't just randomly using letters as labels. Nope. It's using them as digits in a totally different number system. So if we use base 10, what do you think Excel is using? It's using a base 26 system. It makes perfect sense when you see it side by side. Our system, base 10, has 10 digits, 0 through 9. Excel's system, base 26, has 26 digits, the letters A through Z. It's the exact same concept, just with a different number of characters. So what this means is that our little Excel puzzle is actually a classic problem in computer science. It's called base conversion. All we're really doing is converting a number from Excel's base 26 into our familiar base 10. And once you frame the problem like that, suddenly it feels a whole lot less intimidating. Okay, so now we know what the problem really is. The next logical step is figuring out how to solve it. We can actually build a simple, repeatable set of steps, an algorithm, based on this whole base 26 idea. And honestly, the logic is beautiful in its simplicity. Here it is. You start with the first letter on the left. For every new letter you move to, you just do two things. Take your current total and multiply it by 26, and then add the value of that new letter. That's it. Multiply by 26, add the new number. Let's see it in action. Let's try this with our original problem, ZY. We start with a total of 0. The first letter is Z, which we know is 26. So we take our starting total, 0, multiply it by 26. That's still 0, and add 26. Our new running total is 26. Got it? Now for the next letter, Y, which is 25. We take our current total, 26, and multiply that by 26. And then we add 25. So what does that give us? 701. That's it. Excel column ZY is actually column number 701. See? Once you know the trick, that simple base 26 logic, the puzzle just solves itself. It feels pretty cool when that clicks, doesn't it? All right, we've got the logic down pat. But what does this look like when we actually want to tell a computer how to do it? Let's check out how this clean, simple idea translates into some surprisingly elegant code. This one line of code is the entire engine. It's the heart of the whole solution. It does exactly what we just did manually in that table. Ants is our running total, and C is the letter we're looking at. We multiply our running total by 26, and then we add the value of the new letter. It's a perfect one-to-one translation of our logic into code. Now, you might be looking at that last part, C minus A plus 1, and thinking, what is that? Well, it's a really common and clever trick in programming. See, computers store letters as numbers under the hood.
So if you subtract the character A from any other capital letter, you get its distance from A. A minus A is 0, B minus A is 1, C minus A is 2, and so on. We just add 1 at the end to get the 1 to 26 value we need. Super handy. And here's how it all comes together in a simple little Python function. We start our answer at 0. Then we just loop through every character in the column title, and for each one, we apply that exact same line of logic we just talked about. By the time the loop is done, ants is holding our final number. It's so clean, so elegant. And what about how fast it is? Well, this solution is incredibly efficient. The time it takes is directly proportional to how long the column name is. If the name gets twice as long, it takes about twice as long to solve. We call that O of n. And even better, it uses the same tiny amount of memory whether the column is Z or ZZZZZ. That's O of 1. It's basically as good as it gets. So when you boil it all down, what's the real lesson here? This was never really just about Excel, was it? It's a perfect example of how you can find a fundamental mathematical pattern, in this case base conversion, in a place you would never expect. And that skill, recognizing patterns, is absolutely essential in programming and really in all kinds of problem solving. And that leaves us with a final thought to mull over. Now that you know what to look for, what other systems that you use every single day might just be a different number base hiding in disguise? Something to think about.